tomorrow you are having exam and don't have time to read the entire topic of concentration of urine, don't worry. In the next 5 minutes, we'll divide the entire question with the help of one master flowchart. If you understand this flowchart, you can easily revise this answer in the exam. So let's see the bigger picture. How the kidney make this concentrated urine? Now this required a three-step game. First one, the counter current mechanism. It creates the medullary gradient. Remember, the gradient increases from 300 to 1200 milliosmol. Then comes the Vasa Recta, that is the counter current exchanger. It prevents the washout of this gradient. And lastly, the ADH release, which opens the aquaporins in the collecting duct. And these three ultimately leads in formation of concentrated urine. That is, the water is reabsorbed into the hyperosmotic medulla. Thus, this concentrated urine formation is a three-step process. First, create this countercurrent gradient. Second, preserve this gradient. And third one, with the help of ADH, use this gradient. Remember, this plasma osmolality is 300 milliosmol and the urine osmolality is 1400 milliosmol. That's the complete answer. Now here is the first Viva question that most of the students fail to answer. Who create this medullary gradient? It is the loop of Henle. This loop of Henle generates the hyperosmolar medullary gradient and mainly the thick ascending limb part. This thick ascending limb, it actively transports sodium chloride out and it is impermeable to water. Due to this, the tubular fluid, it becomes dilute whereas the medullary interstitium concentrate. And this is a single effect. And this single effect multiplies to form the concentrated medullary interstitium. Remember, exam keyword, countercurrent multiplier creates gradient. You need to remember only one golden rule. Descending limb, water leaves, salt stays. So the fluid become hypertonic. And ascending limb, water stays, salt leave. So the fluid becomes hypotonic. And this happens in thick ascending limb of loop of Henle. Say it again mentally. Descending, water out, ascending, salt out. If you remember this, half the topic becomes easy. Now the next Viva question is, if medullary gradient is created, who protects it? It's the Vasa Recta. Vasa Recta is called as the countercurrent exchanger. It prevents the washout of sodium chloride and urea. Remember, the function of the Vasa Recta is not to create the gradient, but its function is to maintain the gradient. When the blood flows down into the hyperosmolar medulla, water and solute exchange and again goes up, again there is exchange of solutes and water. And ultimately it results in preservation of this gradient. Remember this memory line, multiplier creates and exchanger maintains it. Now gradient is ready. What is the trigger? It is the ADH. When there is water deprivation or plasma hyperosmolality, osmoreceptors in hypothalamus get stimulated and it causes ADH release from the posterior pituitary gland. This released ADH inserts aquaporins in late distal tubule and collecting duct. Now these aquaporins causes massive water reabsorption. That is, the water is reabsorbed into the hyperosmotic medulla. So the urine volume decreases and the urine becomes concentrated. Remember, this ADH is graded. More ADH, more aquaporins and more concentrated urine. This urea cycling also boosts the inner medullary gradient whenever the ADH is high. For exam purpose, remember these three words: hyperosmolality, ADH release, aquaporin causes concentrated urine. This comparison is frequently asked in exam: countercurrent multiplier and countercurrent exchanger. Let's understand under the following headings. First, the structure. Multiplier is done by the loop of Henle, whereas countercurrent exchanger by Vasa Recta. Function of the multiplier is to create the gradient and function of the exchanger is to maintain the gradient. The process of multiplier is active, that is sodium chloride pumps out from thick ascending limb, whereas process of exchanger it is purely passive by diffusion. The flow medium for countercurrent multiplier it is the tubular fluid, whereas for countercurrent exchanger it is the sluggish blood flow. Remember once again this exam line, multiplier creates and the exchanger maintains. Now lastly about the diuresis. Diuresis is increased urine output more than 20 liters per day. There are two main types, water diuresis and osmotic diuresis. Water diuresis, the cause is absence of ADH in diabetes insipidus or heavy water drinking. Whereas osmotic diuresis, the cause is unreabsorbed solute in the tubules, glucose in diabetes mellitus. Water diuresis, the mechanism is distal tubule or collecting duct is impermeable to water. Whereas osmotic diuresis, solute exert osmotic drag holding water in the tubule. Photodiuresis, the urine volume is high but low osmolality, less than 50 milliosmol, whereas osmotic diuresis, urine volume is high but with high osmolality, more than 300 milliosmol. Specific gravity in water diuresis is less than 1.010, whereas in osmotic diuresis it is more than 1.010. Remember, water diuresis is ADH problem, whereas osmotic diuresis it is a solute problem. Now before entering the exam hall, remember normal plasma osmolality is 300 milliosmol, where the maximum medullary gradient is 1200. Thick ascending limb is the dilating segment. Urea cycling contribute the inner medullary gradient, and proximal connective tubule mainly absorb water. Who create the single effect? It is the sodium chloride transport in thick ascending limb. Why the Vasa Recta is U-shaped to prevent the washout of solute. Remember this master equation. Medullary gradient along with ADH at the collecting duct causes concentrated urine. We can remember this visual trick. Thick ascending limb, salt out, water stays. Whereas the descending limb, water out, salt stays. Now go and watch these two videos. First showing how to write the long essay question on countercurrent mechanism, and second showing the flow and diagram trick to never forget this concept. Thank you.